Okay, hello everybody. Jacob here with Smedding Performance again. This is now part 2 of the 632 engine build, where we are building our 10.2 deck height 632 pump gas hydraulic roller big block Chevy. In part 1 of this build, I went over all the block machining, what we're looking for, clearancing everything to fit the block. We also balanced the crankshaft for this motor. Again, this is our Smedding 4.75 stroke big block crank, and we're going to fit that with our Smedding 6.7 length H-beam rods, and then our really cool custom billet comp cam. Not only is this cam billet steel, but it actually has a pressed on old school ductile iron distributor gear, so you can run camshaft gear, so you can run a standard distributor gear and not have to be worried about the steel gear compatibility. So the first step in this application right now for us is we're going to add all the block plugs for this engine, and these darts are really cool. Normally you'll have an NPT taper pipe plug, whereas these use all straight cut O-ring plugs. So we'll get those all installed on the block, and then we're going to install the camshaft and check the cam into play with our button. I install the camshafts dry first, that way I can check to make sure the bearings are perfectly in line. Then I'll push it out just a little bit, come back with our assembly lube, and lubricate each of the journals. Next we have our timing set, which does have a thrust washer on the back of it. I'm going to install just the gear first onto the cam. Make sure that it clears everything. Okay, after messing with it for a little bit, we ended up switching to a rollerized cam button. It's going to be more reliable for this engine, but long story short, the cam in play is perfect now with our timing cover. We have exactly 8 thou fore and aft clearance. Next step, checking the main bearings. Bolts, by the way, go to 100 pounds. Okay, so this is now zeroed out. The distance from this carbide to that carbide is zeroed out to the diameter of these journals. Next, I'm going to take my dial bore gauge and zero it to this micrometer, and then we'll check our clearance in the block. Okay, as we sit with these bearings, we currently have too much clearance. I'm going to take them out, put a smaller diameter set of bearings in it, and then we'll reevaluate. Coated bearings always just look so cool in the engine block. Anyways, these are a smaller size. I have the caps flipped as well. I'm going to reinstall the caps onto the block, and then we'll recheck our clearance. these bearings are still a little bit too loose for where I want them, so I have another set of even tighters. I'm gonna pop them in, and then we should be good. Okay, off camera, I went ahead and swapped all the main bearings out. Got the final correct set that has the perfect clearance I want for this engine. And now I have the fun job of lifting up this 80-pound crankshaft and putting it in that block. Yay. Now that the crankshaft is installed, we'll press on our cam gear and install the timing set. And by press, I mean hammer. All right, the crankshaft is final installed, the camshaft is final installed. Now we're gonna check the rod bearing clearance. That way we can go ahead and final assemble the rod and pistons, and then we will gap our piston rings. The next step in this build is going to be checking our piston deck height clearance so that we can order the correct size and thickness head gasket for this combination. It's important to check this because they make a whole bunch of different head gaskets, and your head gasket thickness directly affects the distance between your piston and the cylinder head combustion chamber. This is known as your quench distance. In a normal naturally aspirated engine such as this one, we're gonna run about 40 thousandths of quench. Depending on the application, you may run, you know, some guys want to target 80, you might tighten it up to 30, it all depends on the application. But this being a naturally aspirated engine, we're gonna run it at 40. So, we'll take our deck height checker, pop it on the piston, find as far up as the piston goes at top dead center. And then we're gonna rock the piston both ways, since there's a little bit of bore clearance there. You can see that? So on the bottom, we're -8 in the hole, and on the top, we're 5 out of the hole. So that averages out to about 1.5 thou in the hole. So we'll just order a standard 40 thou kinetic head gasket, and that will be perfect. Okay, moving forward on the 632 build, all of the rod and piston assemblies are hung together. They have double spiral locks to ensure that the wrist pins never come out. Again, these are our custom JE 2618 forged pistons on top of our Smetting 6.7 length H-beam rods with the ARP bolts. See that right there? Super strong assembly that's going to be perfect for how much power and RPM this engine is going to turn. A lot of people think the strength of the rod only matters with how much horsepower you're making, when in reality the RPM and the weight of the piston really determine a lot on what kind of rod and what kind of rod bolt you use. If you have a really heavy piston that has a really long stroke turning a lot of RPM, the G-forces required to hold on to that piston go up exponentially compared to if you had a really lightweight piston with a shorter stroke. And that's just due to the inertia required to move the piston either a really long stroke or a really short stroke, and then with its weight. So next, we're gonna check the gap on our second and top ring. In this motor, we're running a standard ductile iron top ring with plasma moly coating, followed up by the second ring. This ring pack is a 16/16 by 3/16. Really good, typical street motor stuff. That coupled with our plateau hone is going to give this motor excellent ring seal and really help make a lot of horsepower. So, starting with the top ring first, I'm going to put these in the bores. We will square them up and then check our ring gap. Okay, right here you can see that there is a very small gap in that piston ring. And you might think that's what you want. You want this to be as tight as possible so you get the best seal up. However, with thermal expansion, that ring is going to expand. And whenever it expands, you do not want those ring gaps, tips, to ever touch each other. Because if they do touch each other, they have nowhere else to go. So instead of just expanding until they touch, they're gonna buckle and they're gonna blow this top land of the piston off. So right now, I have about a 4 thou gap in the rings, and we're gonna open those up based on the bore size and the application with how much heat it's going to make in the cylinder to give us a ring gap that we know will be very safe and will never touch, but still get very tight so that we do get good ring seal when we're wide open throttle. After you gap these piston rings, they're gonna leave you a really nasty burr on the bottom of this edge that you've cut. So always come back with a really small diamond file and knock that burr off. I'm gonna put these top rings back in the bore now so I can check the clearance again. And assuming that they are good to go, we'll move on to the second ring. Okay, now that we have all the piston rings gapped, deburred, checked, ready for assembly, we're gonna hang them on the piston rings, make sure they fit really nice in the ringland grooves and there's no friction or burrs, and then we can assemble this monster. Block is totally clean. All the cylinder walls are lubricated. I lubricate the cylinder bores with the Joe Gibbs driven break-in oil. That way the rings have a really nice foundation to start on. Pistons, rods, rings, rod bearings, everything is ready to go. It's time to assemble this. Okay everybody, that's a wrap for part 2 of this 632 Big Block Chevy video series. The short block is all assembled, and this is just such a cool engine. I love building these just awesomely cool, super radical motors that require so much effort and attention to detail. And it's just massive. It's absolutely gigantic. In the next episode of this 632 series, we're gonna go over the cylinder heads needed to feed this many cubic inches, as well as check piston to valve clearance. See y'all then.